wavelengths, often far into the infrared part of the spectrum, even sometimes beyond what Hubble is able to detect well. The Webb telescope will give us more information about some of those very distant galaxies.
The James Webb Space Telescope is the follow-on telescope after the Great Hubble Telescope. It extends the discoveries of Hubble into the infrared spectrum region. We think that the first objects that grew out of the Big Bang material probably happened in about 100 million years after the start. And we think the Webb telescope can pick them up. They're rare, they're hard to find, but they should be there. The farthest we've been able to see with the Hubble telescope goes back about 800 million years after the expansion began. So we think we get much closer to the first objects with the Webb telescope.
Hubble gives information that the Webb telescope cannot give about visible and ultraviolet emission from things in the universe. And when we have all that information coming in at the same time, it's like a banquet of scientific return.
Now when we get the complete picture of every wavelength you can possibly see from ultraviolet to infrared, we hope to have the story of the growth of the first galaxies from the primordial material. So that will be a huge accomplishment that depends on both pieces of equipment, the Hubble telescope and the James Webb telescope working together.
So astronomers are very excited about this probability that we'll have both the Hubble Space Telescope and the Webb telescope operating at the same time for quite a few years. That will give us an abundance of new understanding about the universe. And already right now with Hubble, we're doing preparatory observations for the Webb telescope. We're using Hubble to do things, for example, like surveying distant galaxies to find out which ones would be prime targets for the Webb telescope. In fact, scientists around the world are proposing observations with Hubble right now specifically to help us learn information that will be useful for making the best use of the Webb telescope as soon as it's launched and gets going in its science observations.
I think the Hubble telescope has been the most productive science instrument ever built. In astronomy, there's what we knew before Hubble, and now there's what we know after Hubble. They're so different. Of course, Hubble has now had a life of 30 years, so it's had a long time to make this revolution happen. So it's not all at once. It's a gradual revolution, but it's still a huge revolution. Technology has changed dramatically over the 30 years of life of the Hubble telescope. So you couldn't even have imagined when the Hubble was launched that we would have the wonderful cameras and spectrometers that we fly today. We figured out how to send astronauts, we trained the astronauts, we figured out what instruments could be put in, we figured out how to repair everything that went wrong on the Hubble, and it's still alive. It's today, 30 years after launch. And I am so thrilled to say that our people were able to do that. That's the operations team that makes this possible. It's a miracle as far as I'm concerned, because it didn't have to be that way, but they made it happen.
Imagine living in a modern metropolis full of opportunities, endless sunshine, Hollywood celebrities, and fancy cars. That was the American dream. That was Los Angeles in the early 1940s. But in the morning of July 26, 1943, in the middle of World War II, the sun didn't rise over the city. A throat-burning, noxious gas covered the sky. Entire city blocks faded away.